Namaskar, myself Kumbar I am from Dr.Rajaram Shinde Mahavidyalaya Srigonda. Today we see the Broglie hypothesis about the wave. The Broglie hypothesis Here, the relation between energy and mass of the particle is equal to mc square. This is the famous Einstein's famous relation. This relation can be written like this: mc into c. That is p into c. Here, p means momentum. That is mass into speed of light. That is the momentum. Then P is equal to E upon C. This is the relation between momentum, energy, and speed of light. Then energy can be written like this relation: E is equal to h nu. Here, h is Planck's constant, and nu is the frequency of radiation of the incident photon. Then this relation can be written like this: h c upon lambda. Here, nu is equal to c upon lambda. Then we can compare these two relations, this relation and this relation. Then we get P c is equal to hc upon lambda. Here equation 1 and this is equation 2. Both are energies, and from this equation 1 and 2 we get P is equal to h upon c, and this is the famous de Broglie relation. Here P, it is related, P is the momentum which is related the mass of the particle, and lambda it is the wavelength of wave. And this equation suggests that the smallest particle of matter has dual nature, that is particle as well as wave. Particle as well as wave. Means P, that is a momentum, it is related to the mass of that particle, and lambda, that is wavelength, related to the wavelength of the wave. Then this relation can be written like this: wavelength lambda is equal to h upon p. Here p, it is nothing but mass into velocity, that is a momentum. Then lambda is equal to h upon mv. Then we know that energy, kinetic energy, is equal to 1 upon 3 mv square. This is the kinetic energy of the moving particle, and from this relation we can obtain value of velocity, that is 2e upon m, which is equal to v square. Therefore v is equal to root 2e upon m. Here m is the mass of the particle and e is the energy. Putting the value of e in this equation, then we get that is lambda is equal to h upon mv. Then h upon m into root means 2e upon m. This relation can be written like this: h upon m root m upon 2e. Therefore, this relation can be written like this: h upon root 2me. This is the wavelength of wave. This relation can be written in the form of here like this: E is equal to charge into potential, that is a charge E and potential V. Then wavelength of light lambda can be written like this: lambda is equal to h upon root 2m into E V. Here from this equation we can obtain wavelength of the wave. Here m is the mass of that moving particle, E is the charge, and V is the potential. From this relation we can obtain the wavelength of that moving particle. Here H, the value of H is equal to 6.623 into 10 raised to minus 34 joule second. Then value of charge is 1.6 into 10 raised to minus 19 coulomb. And mass of the moving particle is 9.1 into 10 raised to minus 31 the 27 9.1 into 10 raised to minus 31 kg. When we put the value of these values in this equation, we get lambda is equal to 6.63 into 10 raised to minus 34 divided by root 2 into 9.1 into 10 raised to minus 31 into 1.6 into 10 raised to minus 19 into potential value of the potential applied. And from this relation we can obtain the value of wavelength. This value of wavelength is in an angstrom unit, and the energy used for this purpose is an electron volt. It is the smallest unit of electron volt. Then in 1927, scientist Thomson give satisfactory proof for this hypothesis, that is de Broglie hypothesis, and for this satisfactory explanation of matter wave, de Broglie was awarded by Nobel Prize in 1929. Then wave particle duality. Wave particle, it is the last lecture in this lecture topic, wave particle duality of matter wave. This moving particle has wave nature, and that is a wave particle duality. Means any subatomic particle has both the nature, that is particle as well as wave. Here frequency, that is a nu, and k, that is a wave number, these are related to the wave nature, and mass m and momentum p are related to that of the particle. And this is the wave particle duality of matter wave, and this is the last concept of this dual nature of radiation. In this topic we studied some examples like this. काही प्रॉब्लेम्स आपण या ठिकाणी पाहणार आहोत. त्यातला या ठिकाणी एक प्रॉब्लेम मी घेतोय. व्हॉट इज द स्पीड ऑफ अ प्रोटॉन? What is the speed of a proton having de Broglie wavelength, having de Broglie wavelength of 0.08 angstrom. Then, according to de Broglie hypothesis formula here given, what is the speed? Here we want to determine speed of that proton. Then wavelength of light 0.8 into 8 angstrom can be converted into meter, 0.08 into 10 raised to minus 10 meter. And the moving mass, that is the mass of the proton, is 9.1 into 10 raised to minus 31 kg. That is m is equal to 9.1 into 10 raised to minus 31 kg. And formula for this, lambda is equal to h upon p. P, it is nothing but momentum. Here h upon mv. Here we want to determine speed. That is v is equal to h upon lambda into m, and the value of h h is equal to 6.6323 into 10 raised to minus 34 joule second. This is the value of Planck's constant h. Then we get v is equal to 6.623 into 10 raised to minus 34 divided by 0.08 into 10 raised to minus 10 into mass of the proton, that is 9.1 into 10 raised to minus 31. From this we can calculate the value of speed, that is 6.623 into 8 into 10 raised to minus 34 powers of 10 plus 10 plus 31 divided by 8 into 10 raised to minus 2 into 9.1. That is value of this 6.623 into this minus 34 plus 41. 10 raised to minus 34 plus 41 divided by 8 into 9.1 plus 2. 6.623 into 10 raised to plus 9 divided by 872. The value of speed that is can be obtained from this relation, and the value of that speed is by using log table we can obtain the value of speed of the proton. ठीक है, then okay, धन्यवाद.